Okay, welcome back to the development blog video. So in the last video we looked at the overall design of the save system in Estranged Act 2. In this video we're going to look at the actual code and dive in at a very technical level about how the actual the save state for the world is built. So in the previous video I did show you a slide, let's bring it up again, about the tree hierarchy of the state. So we start with the world state, we have levels inside that world. Inside those we have sequences and actors, and inside the actors we have components. So I'm going to go into those structures first. So let's go to game state. So we'll start from the bottom. So at the bottom we've got component state, and that has component data, which is the serialized component data. I'll go into that in a second. The name of the component, because when we restore we want to go and find it by name and then restore it. The transform of the component and the class. Then we have the actor state. The actor has actor data, which is the serialized actor data. It's got an array of component states. It's got the name of the actor, that's how we match it up with the actor that's in the world when we restore. It's got the transform of the actor, the class, and we also store away actor tags, because in Estranged the tags are modified at runtime. So it's important to restore those. Let's have a look at our tree hierarchy again. So we've got level sequence state as well. So we've done actors, we've done components, level sequence state. So level sequence state has three properties. It has the position of the playback, the name of the level sequence actor, and whether it's playing or not. So very simple things there. So then we're looking at the level state. So if we go back into the code, here's our level state. It has an array of actor states and an array of sequence states, and also the level name. And the final top level is the world state. And the world state has this persistent level state, and it also has an array of streaming levels. Because in Estranged, in a typical level, let's take this one for example, if I do stat levels, which shows you all of the loaded levels, you can see there's 4 streaming levels in this, and the persistent level at the top. And the save system needs to cope with all of that. It needs to serialize all of the actors in each level and then restore them. So that's why we store it like that. So let's go into the actual code that makes the world state. So we've got this method serialize world. So I'm going to actually just invoke it. I've got a breakpoint at the end here. So we'll do some stuff, pick up a box, drop it, just say serialize. So we'll inspect this world state that got built up. So let's have a look at that. So you can see we've got our persistent level state. So moved actor states is something very Estranged specific. I'm not going to go into that. But when I picked up the box, that became a moved actor. So that's in there. So we've got the level state, which has one actor in this level name, which is none because it's the persistent level. We've got streaming levels, there's 4 of them as we saw in the game. It's BO5 lab upper, clearing, office and night. So we'll go inside lab upper. You can see that has 138 actor states, and it's got the level name stored away in there, so we can match it up when we restore. So going into the actor states here, can see that we've got a whole bunch of actors. I don't think we'll have any components to see at the minute. We could probably find the fisherman. Yeah, there we go. So we looked in the persistent level state, we've got the fisherman. If we expand out that actor state, you can see we've got the actor data, which is just the serialized binary from the actor. There's a property name there, save, B has flashlight. So that's all of the property data on that actor. This one has 5 components, so it's got the character movement component, health, battery, stamina and oxygen. So that's all of the state that gets stored away with the player. So that's the hierarchy. That is a one-to-one mapping of the tree hierarchy I showed you in the slide earlier. So we'll just step into this code. So the first thing it does is it gets the world from the world context object. This is all invoked via blueprints. So this world context object is given to you for free when you call this from an actor. So it just fills it with the current object that you're using, and then we can get the world out of that So can we see where this came from? This was actually called on the player because it's our quick save. So that's our context object. The first thing we do is just serialize the persistent level. So serialize level, if we look through that, it loops all of the actors. If it's a child of the level sequence actor, it serializes the actor as a sequence. And that just pulls out those three properties. So we've got the actor name for the sequence, the position, and whether it's playing or not. So that's that done. Then it'll look to see if the actor is implementing the save restore interface that we looked at in the previous video. If it is, it'll create an actor state, it'll serialize the actor and add that to the level state. So let's look at serialize actor very briefly. So here we're storing away the actor's name, its class, its world transform, its tags, and then we're calling this serialize low level function. So if we look at this, this is actually doing the kind of nitty-gritty of the serialization. So this is initializing a memory writer. It's instantiating one of the classes that we went into in the first video, which is the save game archive. And this archive is just inheriting an Unreal Engine struct, but setting that it wants to save only properties that have the save game decorator on them. So then it's writing to that memory writer, and then just calling uObject. So everything is a uObject in Unreal. So uObject serialized to the archive. So we'll go back to our method here. It does that for each component as well. So for each actor component inside that actor, it goes and calls serialize component. So it builds up a similar thing with the component name, the component class, the component data, which is again serializing the component. The component transform stores that away. If it's a scene component, if it's just a regular actor component, it ignores it, and then it returns that. So that is pretty much serializing the level. So then we go back to our world state here. We've serialized the persistent level. This bit here is a little bit of specific handling for moved actors in Estranged. It's not a secret or anything, I just don't want to go into it in this video because it's a little bit complicated and it'll make the video last a long time. So the next thing the code does is it loops through the streaming levels. You can see there's 16 in this persistent level, but we only care about the loaded ones. So it does that, it loops through, it serializes the level, each one. It sets up the level state structure and then adds it to the streaming level states. So we ended up with 4 like we saw earlier. And then that's just returned back to blueprints, and because it's just a regular structure, it gets saved to disk. So that's our save. I'm going to put a breakpoint on the restore world method as well. So we'll put a breakpoint there, and we'll hit F9, which is our quick load button. So we'll just give it a little while to load in the map from disk. So we'll go through here. So again, this is basically the thing I just showed you, but in reverse. We've got the world, we go and call restore level. That was for the persistent level there. So then it loops through all of the actor states. So we'll see the first one, it's looking for the player, quite appropriately. So it's looking, I've got a little shortcut here, little helper in our gameplay statics class. Find actor by name in level, because we've got the level, we've got the actor name, we want to get the actor. So that just loops through the actors in the level, and if the name matches, it will return it. So we've found the actor, let's see. Yep, it got the fisherman. That's a valid pointer. Restores the actor, and restore actor does the reverse of serialize actor. It just restores the actor tags, sets the transform if there's no attached parent, and then calls restore low level, which is exactly the same as serialized low level, except it uses a memory reader instead of a memory writer. And the type of archive tells this serialize method on uObject what to do. So in this case, it's going to read rather than write. So we'll go back up here. So that's restore actor. Then we've got each component inside the actor. So for the fisherman, we did have a few components. We've got 5 there. So this is a good example. If I go inside restore component, so the first thing it does is it finds the component by name. So let's just skip that through. So it found the character movement component. If it's a scene component, it restores the transform. Then it calls restore low level to restore all of the properties on it. So if we look at the component data on that, save underscore max walk speed. So that's restored that completely, and then it will do the other components, etc., etc. And the final thing it does is that it will restore level sequences. So I'm going to let this go. So you can see it found a level sequence. Which level are we in now? So still the persistent level. So this is a level sequence. So I don't think that's right. I'm not sure why that says persistent level. Anyway, so it found a level sequence, truck drive by. So the sequence state is that it is pre-start. It's not started yet, it's not playing, and the actor name is ls underscore truck drive by. So then we call restore sequence. It does the same thing. It tries to find an actor by its actor name. In fact, I think I could use the method from the restore actor, the helper that we were using to find the actor by name. But anyway, I can rewrite that later. It restores the level sequence actor, sets the playback position from the structure, checks whether it's playing, tells it to play. If it's at the end, it also tells it to play because that helps to restore the final frame of the level sequence and kind of apply that to the level, otherwise it doesn't tend to. And that's it. After the sequences are restored, then the level is considered completely restored. So now if we go back into our game, we can see that the box is restored to where it was. So I just want to dive into the one of the aspects of this, which is the interface methods, which I didn't really touch on in this. But you see when we are restoring and serializing actors where the code is peppered with the execute on pre-save, execute on pre-save, execute on post-save, etc. And the way that's being used in code, if we look at the player, for example, is that before saving, it will take any state that it can't persist otherwise. So if this state is contained within components that you don't manage, so for instance, the flashlight, that is a spotlight component, which Visual Studio may have trouble finding. There we go. So it's a uSpotlight component. I don't own any of the properties in that object, so I need to mirror them. So I came up with this convention, which is just save underscore thing. So whether you have the flashlight is dependent on whether the flashlight is hidden in game. Whether the flashlight is on is dependent on whether the spotlight is visible, whether we're zooming, whether zoom is desired, the held actor name of the actor you're currently holding. That gets set from just picking up an actor. This will be called crate something or other. That gets set to that. When we restore, we take those same variables and then apply them back to those classes. So if the save underscore flashlight is on, we toggle the flashlight on. If we're zooming, we set that we're zooming. So if we look at the declaration of those variables, just cancel that, it'll probably still find it. Yep, so all of these are contained at the bottom of the class and they have the saved game attribute on it. I think that's it for the development blog video. If you're interested in this code, I can post it on GitHub. If you have any questions, put them in the comments or send me an email to alan@alanedwards.com. Thank you for watching.